Here on this part, we have rates of change and tangent lines to curves. Average speed when f of t measures the distance traveled at time t. Average speed over this time interval starting at t1 and ending t2, that is equal to distance traveled divided by elapsed time. So what we have in numerator on top, that is based on this function f of t. So using the ending point at time travel, we have f of t2 minus f of t1. So t1 is starting point in time travel divided by the distance between these 2 points in time travel. We have t2 minus t1. Definition: the average rate of change of y equal to f of x with respect to x over the interval x1, x2. That is change in y divided by change in x. So this is equal to, based on what we have here, using this function f of x. In numerator on top, we have f of x2 minus f of x1. So find the difference between these two. Divided by what we have in this interval. We have x1, x2, starting, ending point. So find the difference between these two in denominator, x2 minus x1. This is equal to, in numerator, we have f of x1 plus h. So what we have here is interval of length h starting at x1 minus f of x1. So in denominator, we used h for x2 minus x1. This x2 minus x1 is distance between these 2 points, starting and ending point in our interval. So this h is length of our interval. And because of having this h in denominator, that cannot be equal to 0. So we cannot use 0 in denominator. Here we have this graph using these 2 points P and Q. P is x1, f of x1, and Q is x2, f of x2. Here this one is change in x. H is length of our interval. This part here is change in y. And here we have this line containing these 2 points P and Q. That is called secant line that cuts through the curve. Using this formula, we cannot calculate the instantaneous speed at exact moment t0 by using 0 in denominator, because what I said, if you had 0 in denominator, that will be undefined. But we can use this to find average speed over shorter and shorter time intervals. Here in this example, we will find the average rate of change of the following functions over the given interval. Part A, our function is f of x equal to 3 times x cubed plus 3. Our interval is 2, 5, starting point is 2, and ending point is 5 in our interval. So we have to find change in y divided by change in x. So in numerator, we have f of x2 minus x1. So for f of x2, we have 3 times x2 cubed plus 3 minus for f of x1, we have 3 times x1 cubed plus 3. So we have 3, 2 cubed plus 3 for f of x1 divided by x2 minus x1, 5 minus 2. So this one is x1, here is x2. So this is equal to 3 times pi cubed is 125. Plus 3 minus 3 times 2 cubed is 8. Plus 3 divided by 3. So what we have in numerator is 378 minus 27. So we have 3 times 125 plus 3 is 378, and 3 times 8 plus 3, that is equal to 27 divided by 3. Subtracting these two numbers, we have 351 divided by 3. Our answer is 117. So this is average rate of change for part A. Part B, f of t equals to 3 plus cosine t. Our interval is negative 3 pi over 2 and pi over 2. So this one is t1. Here is t2. We have to find change in y divided by change in this case, instead of x, we have t, so I'm going to use change in t in denominator. Assuming that our y is equal to f of t. So change in y in numerator, change in t in denominator. In numerator, we have f of t2 minus f of t1. In denominator, we have t2 minus t1. So we have 3 plus cosine t1 is pi over 2 minus 3 plus cosine t2 is negative 3 times pi over 2 divided by pi over 2 minus negative 3 pi over 2. So this is equal to 3 plus cosine pi over 2 is 0 minus 3 plus cosine negative 3 pi over 2, that is 0, divided by, here negative times negative is positive. So now what we have in denominator is pi over 2 plus 3 pi over 2. So this is equal to, we have 3 minus 3. And in denominator, we have pi plus 3 pi is 4 pi divided by 2. So we have 0 divided by 4 pi over 2. So the answer is 0. So this is the answer for part B, average rate of change. Nick is driving along a highway and he passes a milepost 40 at 11 a.m. After a quick pit stop, he gets back on the road in time to pass milepost 70 at 11:30 a.m. Here on this part, if we had this question, what was his instantaneous speed at 11:12 a.m.? We are not able to answer that question. So in that case, if asking for instantaneous speed, we're being asked for the speedometer reading. So if this time was when he stopped his speed will be 0. But we don't know the exact time that he stopped. So that's why we're not able to find instantaneous speed in this case, in this example. So our question is, what is his average speed over the half hour? So average speed is equal to distance traveled divided by time elapsed. Distance is 70 minus 40 miles divided by time elapsed. Here we have half an hour. So it's 0.5. 30 divided by 0.5, that is equal to 60 miles per hour. So this is our answer for this part. Here we have possible graph of position versus sign. This part is the flat part, which is when he stopped, since he was not covering any distance. So the average speed that we calculated is this slope of this line. Which cuts through the graph. Here on this part we have this line L is tangent to the circle at this point P if it passes through P perpendicular to radius OP. So this one is perpendicular. The tangent line to curve at this point P is a line through P whose slope is the limit of the secant line. Slopes at Q when approaches P from either side. So here we have this point on the left side, we have our point as P, and this point Q that approaches from right to left to P. And here on the right side, again, we have this point P, and Q approaches P. Here in this example, we are able to find instantaneous speed. The position of a train along a track for the first 30 seconds after being moving off of the station is modeled by the equation S of t equal to 3 times t squared, where t is measured in seconds and s is measured in feet. What is the instantaneous speed of the train 5 seconds after it starts moving? So here is our time interval 5 and 5 plus h. H is length of our interval. So finding average speed over short time intervals 5 plus h. So to find average speed, we have to find change in s. S is our function divided by change in t. So starting with the first column, for changing t, I'm going to have 1. So here for h, instead of using 0, we're going to have shorter and shorter time intervals. So we'll use 1 first, and then I'm going to use smaller numbers. Second column, we have s of 5. So instead of t, we have 5. Using this function, we have 3 times 5 squared. So the answer for this part is 75. Then we have to find s of 5 plus h. H is 1. So 5 plus 1. Here we're going to have s of 6. So using 6 instead of t in this function, we have 3 times 6 squared, and that is 108. Now here on this column we have change in S. So we have to subtract these two columns. 108 minus 75, that is 33. And finally, finding average speed is change in S divided by change in T. So it's 33 divided by 1. That is equal to 33. So making time intervals smaller, for H, I'm going to use 0.5. S of 5 is, again, 75. S of 5 plus H, in this case, is 0.5. So S of 5.5. Using 5.5 here in this function, we have 3 times 5.5 squared. This is 90.75. Change in S. Subtract these two numbers, 90.75 minus 75, that is 15.75. And finally, finding average speed is 15.75 divided by 0.5. So the answer is 31.5. Again, making this one smaller, this time interval is 0.1. So here again, S of 5 is 75. S of 5 plus 0.1. So using 5.1, instead for T, we have 5.1 squared times 3. That is equal to 78.03. Subtracting these two numbers to find change in S. That is 3.03. Average speed, 3.03 divided by 0.1. The answer for this part is 30.3. So smaller number, here we have 0.01. Here again we have 75. In this case we have S of 5 plus 0.01. So for T we have 5.01. Use that here in this function. 5.01 squared times 3 is equal to 75.3003. Subtracting these two numbers, the second and third column, we have 0.3003. Average speed, 0.3003 divided by 0.01. That is equal to 30.03. So I'm going to have one more here. And a smaller number, it's 0.001. Here again we have 75. On this part, the third column, we have to find S of 5.001. So it's 5.001 squared times 3. That is 75.030003. Subtracting these two columns, the second and third column, here we have 0.030003. I'm finding average speed. This is equal to 30.003. So based on what we have here as a length of time interval, so this column tends to 0. So we started with 1 and then we use smaller numbers. The average speed is tending towards the instantaneous speed. So again, as the length of the time interval tends to 0, the average speed is tending towards the instantaneous speed. So based on what numbers we have here in the fifth column for average speed, we can guess that the value of the instantaneous speed 5 seconds after the train starts moving is 30 feet per second. Because here we have 30.003, and if we use smaller numbers, our guess is that our answer for instantaneous speed will be 30 feet per second. Now we're going to have exact calculation. So the key is not to pick a specific time interval length, but instead pick a generic time interval of length h from 5 seconds to 5 plus h seconds. So average speed is equal to distance traveled divided by time elapsed. So numerator, we have to find the distance between these two, s of 5 plus h minus s of 5 divided by 5 plus h minus 5. So our time interval is 5, 5 plus h. This is equal to, our function was st equal to 3 times t squared. So we have 3 times our t2 is 5 plus h, and our t1 is 5. So here we have f of t2 minus f of t1 divided by 5 plus h minus 5, that is equal to h. Here we have to simplify what we have in numerator. So 5 plus h squared, that is equal to 25 plus 10h plus h squared. 5 squared is 25. Multiplied by 3. So simplify what we have here on top. We have 75 minus 75, so that part is 0. And what's left is 3 times 10h plus 3 times h squared divided by h. So here we can factor. Simplify, the answer is 3 plus 3h. So here is what we have for average speed. So for any time interval of length h starting at 5 seconds, the average speed will be given by this formula, 30 plus 3h. So let's check this against the average speed that we had in this table, this part. So if h equal to 1, average speed is equal to, using this one, 30 plus 3 times 1, that is equal to 33. So 33 feet per second. If h was equal to 0.01, average speed is equal to 30 plus 3 times 0.01 is equal to 30.03 feet per second. And if h was equal to 0, average speed is equal to 30 plus 3 times 0 equal to 30 feet per second. So this one does agree with our guess. Now here I have a graph of train position versus time. And I have these 2 points. Based on what we had here in this table. When h was 1, we had t equal to 5 and s of t was 75. So here using that point 575 and using this point s of 5 plus 1, so s of 6, the answer for that part was 108. So the second point was, and that graph was 6, 108. So this line containing these 2 points is called secant line that cuts through the curve. Based on these 2 points, if we try to find slope of this line, that will be equal to 33. I'm going to have another point that is closer to 575. For example, this one. It's 5.5. When t is 5.5, the answer for s of t is 90.75 based on the table that we had. And again, this line is secant line containing these 2 points, 575 and 5.5, 90.75. And slope for that line is 31.5. I'm going to have another point that is closer to this point 575. So I have 5.01, 75.3003, which is closer to this point 575. Based on these 2 points, our slope is 30.03. So here again, I draw this line connecting these 2 points. So this is secant line. So as you see here, when we let the time interval get smaller and smaller, then the points get closer and closer together on the curve. So the last one that we did was 5.01, 75.3003. That is very close to 575. If we let the time interval distance go to 0, what we are going to end up with is the line that just touches the curve. Right at the point 575. It's right here. So I redraw this graph. That was the relationship between train position and time. Here on this part, I only have this point 575, so you can better see what this line is. So this line is called the tangent line to the curve. And that's what we get when we take the limit as the time interval goes to 0. So the slope of the tangent line looks like it equals the slope of the curve at that point exactly. It also seems like the instantaneous speed should be equal to this limiting process on the average speeds. So the slope of the tangent line is going to be the instantaneous speed, and it's going to be what we get when we take the limit as that time interval goes to 0 on the secant line slopes or on the average speeds. So here I summarize what we covered in this section. Average speed approaches instantaneous speed as length of time interval approaches 0. So for any function, the average rate of change approaches the instantaneous rate of change as the length of the independent variable approaches 0. And for any graph, the slope of the tangent line at the point is equal to the limit of the values of the slopes of the secant lines with one end fixed at the point. Example, find the equation of the tangent line to the graph of f of x equal to 1 minus x cubed at x equal to 3. Since the y-coordinate at x equal to 3 is 1 minus 3 cubed, so it's 1 minus 27 is equal to negative 26. So f of 3 is equal to negative 26. We can use point slope form to write the equation for the tangent line as y minus f of 3, which is negative 26, equal to slope of tangent line. So this is m, and that is tan for slope of tangent line, times x minus what was given for x here is 3. So this is based on y minus y1 equal to m times x minus x1. So the slope m is the instantaneous rate of change of f of x at x equal to 3. So as before, we will calculate the average rate of change over an x interval of length h. So we want the slope of the secant line connecting the points 3 f of 3 and 3 plus h, f of 3 plus h. So our slope is f of 3 plus h minus f of 3 divided by 3 plus h minus 3. And that's equal to f of 3 plus h minus f of 3 divided by, in denominator, we have h. Our function is 1 minus x cubed. And we have the answer for f of 3 was equal to negative 26. So we have the answer for f of x1. We have to find the answer for f of x2. For x2, we have 3 plus h. So 1 minus x cubed, in this case, is 1 minus 3 plus h cubed minus f of x1 is negative 26 when x is 3 divided by h. So we have to simplify. Here we have 3 plus h cubed, and that is equal to 27 plus 9h squared plus 27h plus h cubed. And here we have negative times negative, we have positive 26. Here I applied this negative sign. So negative times 27 times 9h squared times 27h times h cubed. Now here we have 1 minus 27 is negative 26 plus 26, that part is 0. So what's left here, we have negative h cubed, negative 9h squared, and negative 27h. So the answer is, for this part, after simplifying, when we have a numerator, negative 27h minus 9h squared minus h cubed divided by h, factor So what we have here on this part is negative 27 minus 9h minus h squared. And now, using 0 for h, our slope is negative 27 minus 9 times 0 minus 0 squared. So the answer for our slope is negative 27. Now that we have our slope, the equation of the tangent line is y plus 26 equal to negative 27 times x minus 3.